Today we're going to look at quadratic equations again, everybody. So earbuds, things like that, Chromebooks closed, phones away. Okay, come on. All right. The basic quadratic equation is y equals x squared. But today we're going to look, when we have a quadratic equation, you'll see on this page, it says y equals ax minus h squared. I'd like you to change that. That's supposed to be a minus h plus k. And we're going to talk about what all those things are. What we're going to have is we're going to have numbers in there, and we're going to learn what those numbers do and how it changes the graph. Simply talking about the graph, here's the basic graph, y equals x squared. We graphed it quite a few times. If you remember, we would graph a point, then we'd graph one here, and we'd see that parabola. So what we're going to talk about today are the different ways we can take that parabola and what we do with it. The one on here that I've got, the black one is the parent function. So sometimes we might shift the graph 2 to the right. Sometimes we might shift it 2 down. Sometimes we might shift it 3 to the left and 1 up. And that's what the graph would look like. And that's what we're going to see. By looking at the equation, you should be able to tell what happens. And there's other things that can happen as well. Okay? So we're going to talk about those. So first of all, you notice the first thing that you broke down by the negative. If you see a negative on the A, in other words, whatever number's in front here with this A, if you see a negative, we call that a reflection on the x-axis. Well, what does that mean? That means it goes from being a parabola that opens up to a parabola that opens down. Because if we do a reflection simply looks like this. It takes the equation, the parent, the black parabola, and flips it to the green parabola there. It reflects it. So if we were to look at that, down below we have 3 examples, A, B, and C. This one doesn't have an A, so we're going to put an A on it. But which ones, A, B, and C, do you see a negative out in front that means it would flip it upside down? Which one? A, B, or C? B. Okay? So B, it says identify the transformations. The transformations, we're transforming it. They're the things that happen. So we just started. I just couldn't wait too long. This one will reflect on the x-axis because you see that negative in front. The other 2 will not. We're on the bottom of page 4 in the notebook. And you'll see a little table. We filled these things in on there, and we just started explaining the first one. If you see a negative on A, it reflects it on the x-axis. Of the 3 examples I have down below, only one of them reflects on the x-axis. So it'll be a parabola that's upside down. That means these would be parabolas that open up because they're positive, and this one would be the only one of the 3 that opens down because of the negative. And that's what the reflection does. Next, there's other things with A. If A happens to be negative, it reflects it. But now we've got things with what we call a vertical shrink and a vertical stretch. If A is less than 1, then it is called a vertical shrink. If A is greater than 1, it's a vertical stretch. What do I mean by that? And there's one way I like to look at that. So again, here's the idea of the reflection. So I'm going to get rid of the reflection there. And we're going to look at the basic equation, the parent function. The parent function, what I like to think of is if your little brother or your little sister were standing in front of you and they had their arms up in the shape of a parabola. If you were grabbing onto their wrists and you lifted your little brother up in the air. Ever done that? Lift a kid up in the air by their hands. come on. Who's ever lifted a little kid up by their hands? We've all lifted them up.
Does head work?
Not by their hands.
Does
When
head
I
work?
work their bones.
When you grab their hands, their arms, that's
Not
what
by the way.
What about their head? Is that where we're
Wow. So anyway, if you did that, if you lifted them up, half of you did, half of you think it's like crazy or something. I don't understand. So you never like held a kid and held them like this. So you grab them by their waist to spin them around like this then?
Oh, I throw.
Okay.
Yeah,
So,
exactly.
all right. So anyway, so anyway, you if you picked them up, their arms stretch up in the air, right? That's called a vertical stretch. Okay, so can you see? Here's the idea. Oh, stretch. Now, what does that look like? That has to have a number bigger than 1. So like y equals 2x squared. The graph is taller. Or it could be this. It can be a fraction, but that fraction, if I divide it, it's got to be bigger than 1. 3 divided by 2 gets me 1.5, and it's bigger than 1. So that's a stretch. Well, what's a shrink then? A shrink is something like this. And it's the idea, if your little brother or sister were in front of you and they put their hands up like this, and you just push down gently on them, that their arms would go like this. But look at the shape of the parabola, right? The shape of the parabola goes like that. So that is a vertical shrink. It gets shorter. What do you think this one is with the number 3 out in front? Okay, so we say that is a vertical stretch. That one will be taller. It will be this idea. Arms pulled up. What's this one going to be? Ignore the reflection. Just look at the number. Shrink. What's that one? Shrink. Okay? It's 1/4. It's a small number. That'd be like 0.25. If you don't know, you take and divide it. But whenever the top number is 1 and the bottom number is bigger, it's going to be a smaller than 1 number. Decimal. Okay? So, you understand that a little bit? Whether it's going to stretch or shrink? Making sense? Okay? So now, next, the h part. In here, in this equation, it says x minus h squared. What happens in parentheses is something that is opposite and it moves, and that stands for left or right. So if you want to write the words left or right, it'll move it to the left, it'll move it to the right. So for example, coming back to our parent function, if I have the equation y equals x squared, that's our parent function. That's the graph there in black. But if I go y equals x minus 2 in parentheses, it has to be in parentheses. That will do the opposite of what we think. We might say, well, minus 2, that would move it to the left. But minus 2 moves it 2 to the right. Okay? So instead of being here, our graph moves 1, 2 to the right because of this. So this is right 2. So what happens if we say that would move our graph 1, 2, 3, 4. Left 4 because it's a plus. So what happens if I have this? That doesn't move it left or right because notice there's no what? Parentheses. Okay, so coming to our examples. If we look at part A, does that one move left or right? Do you see any parentheses? No. So part A, we're going to leave it. Part B, does it move left or right? Which one? Right 2, because it's x minus 2. So that one we say it moves right 2. How about this one? Seeing if you know, what is it going to move? Right 10. Okay. Remember, the negative, you would think the negative moves left. Both these have the negative, so this one's right 2, right 10. Okay. Next, the last part, k. On the equation, when you're at the end of this, it says plus k. That will move up or down, but this one, notice I don't say the word opposite in there. This one does what it's supposed to. So a plus moves up, a minus moves down. So, in terms of our parabolas, this x plus 7 here would have taken our parent function and moved it up 1, 2, 3, 4, 5, 6, 7, and it would be up 7. Okay? Missed a little bit, but we get the idea. The graph moved up 7. So, on here, what do you think happens to this one? Down 2. Good. What do you think happens to this one? Up 4. What do you think happens to this one? Down 3. You see a 3 on there?
Down 10.
Down 10? No.
Up 10.
Nope.
Stays the same.
It doesn't move up or down. That one moved, we already did the right 10, so the 10's already taken care of. So what you have to notice is it in parentheses or not? If it's in parentheses, that's a left or right. If it's at the end, it's an up or down. Now, notice, this one did 2 things. Vertical stretch of 3, down 2. That's it. It did 2 things. This one did 4. It reflected because of the negative. It's half as tall, which is called a vertical shrink of a half. Should say the number as well. This one I should say vertical stretch of 3, so you can add those numbers on. This one is a vertical shrink of 1/4. Then it went right 2 and up 4. All right. Now, we sometimes have to do the opposite. We're told what it does. So in part A, here it says it opens down. So if it opens down, that's also another way of saying it reflects. So y equals, what's the first thing we should see? If it reflects. A negative. Okay? That's how it opens down. Shifted left 3. So left and right are in parentheses. If it goes left, it should be what in parentheses? X plus 3. Good. And then you put on the squared. Remember, the x is always squared. And then it says up 2. So what do we put at the end? Plus 2. Okay? Now B, narrowed by a factor of 3. This is also what we call the stretch. So it's a 3 out in front. You might see different terms that way. Then it says shifted right 4. Right 4. X minus 4. Down 3. Minus 3. Okay, now this one, we'll talk about these more tomorrow, but I'll give you, if this one, it looks like it goes up 1 square and over 2. Up 1 square and over 2. This one would be half as tall. It's a wider equation. All right, half as tall. Then, did it move left or right? Or did it move up? What do you think? Moved up. So left or right, it didn't move. So I'm not going to put anything in parentheses. How many did it move up? The scale says it's up 2. Okay? All right. This one. I'm going to say this one just hits right on, so I'm not going to worry about the scaling of this one. I think it was supposed to hit right on the 1 and 1. But it definitely moved from here. It moved left 3 and down 2. So left 3 is a plus 3. Down 2 is down 2. There's a worksheet in the packet, and I don't think I put it in the right order. So can we go in the worksheet to the one that says it's near the back? Sorry, I put them in the wrong order, but I just left them in the same order. It says 9.1 day 4. So I'm going to do a couple of these with you. We're going to stay on video yet. We're going to look at number 1. Number 1 says y equals 3x squared plus 2. And then it has a blank. And you're supposed to say what transformations would have happened. Okay? Did it reflect? We don't put it. What does the 3 do? Vertical stretch. So, vertical, you can abbreviate vert, stretch, 3. What's the 2 going to do? Move it up 2. Okay? I'd like you to try number 2 on your own, and then we'll check it.
You gave me all 9.1.
What?
You gave me all 9.1.
All right, what did this one do? What did it do? Yeah. What did it do? Reflect on X and down 1. Okay? All right, now let's jump to number 7. Number 7, you have to write the equation. So you're writing the y equals something, and you have to base it on what they told you it did. So see if you can try number 7 quickly. So it says it opens down, so it's y equals, what's the first thing you write? Negative, because that's the reflection, open down. Now it says shifted up 10 and right 3. So this is a little tricky because they have them in the reverse order. Left and right goes in here. If it's right 3, it's what? minus 3. Good. And then we put the squared, and then up 10 is plus 10. Okay? Number 8. Try number 8. Then we're going to try number 10 together. Y equals negative x plus 3, because it's left 3. That's a little tricky. They give them in the wrong order, but then what? Minus 8. Good. All right, number 10. Number 10 is given a little bit different. It says it opens down, so it's y equals negative. Wider by a factor of a third, so that's going to be the 1/3. But now it says the vertex is at negative 3, 1. This is telling you x moves left 3. So left 3 is x plus 3. This is telling you y moves what? Up 1, so it's plus 1 at the end. Finish that up.